Let's practice our exponent properties together, but more specifically in this video, we're going to focus on the quotient of powers rule. Now, real quick, if you'd like to download a free copy of this PDF, you can find a link in that description box below, as well as an annotated PDF answer key as well. Let's jump right into it. For number one, notice right away that we have this fraction bar, which means we have a quotient or division, and we do have the same base here of x and x. And if we have those same bases of x, then we can go ahead and use our quotient rule or quotient property and go ahead and subtract these exponents. So going ahead and rewriting this, we can rewrite this as x to the, and it's going to be the 8 minus 5 power. So when we have a quotient or we are dividing, we can go ahead and write the same base of x and then subtract their exponents. Subtracting 8 minus 5, we can just rewrite this as x raised to the third power, or x cubed, and this is our more simplified expression. In number two, notice we have a very similar type of problem where we have a common base of y and y, so we can go ahead and use that property again. That quotient property lets us know that because we have the same base of y, we can go ahead and subtract these exponents of 9 and 2. So we're going to go ahead and write this base of y, the same base here, and then we take the exponent for the numerator and subtract the exponent in the denominator, so 9 minus 2. Next, we can just subtract 9 minus 2, and that's going to be saying that we have y raised to the 7th power, and that would be our simplified expression. In number three, we have another similar expression, but we have these bases of x instead of y's. And now if you don't see an exponent on the denominator, keep in mind there's an invisible 1, so that's x to the first power. Since they have the same base of x, we can use that quotient property and go ahead and subtract 6 minus 1 for those exponents. So this is going to be x raised to the, and we're going to just rewrite this as 6 minus 1 power. Now 6 minus 1 is going to be 5, so our simplified expression here is going to be x raised to the 5th power. Here's number four. For number four, we have the common base of y and y here, which means we can use that quotient property and go ahead and subtract these exponents and write it as one base instead, since we have a quotient here. So we can write this as y raised to the 14 minus 5 power. Now 14 minus 5 is going to equal 9. So more simply put, we can write this as going to be y raised to the 9th power. For number five, we have a slightly more complicated expression here. Now, keep in mind that we can keep using that quotient rule as long as we have common bases. So let's take a look at this x and x here. And since they have the same base, we can go ahead and rewrite it as one base as long as we subtract their exponents from each other. So rewriting this part, we're going to have x raised to the, and this is going to be the 7 minus 2 power. That's going to be for the x base. Now that we're done with the x's, let's take a look at the base of y. So we have this y to the 5th power and y to the 3rd power. Since those have common bases of y, we can go ahead and subtract their exponents as well. So we're going to go ahead and multiply this by y raised to the, and this is going to be the 5 minus 3 power. Simplifying this a bit, we can just go ahead and write this is going to be x to the 7 minus 2 power, which is going to be to the 5th power, multiplied by y. So I'm going to just write y, and then 5 minus 3 power is going to be to the 2nd power. So x to the 5th power times y to the 2nd power would be our simplified expression. For number six, notice that we have these common bases of a and a, but then we also have these common bases of b and b. Taking care of the a's first, we have this a to the 6th and a to the 4th power, so going ahead and writing it using just one base of a, we can write this as a to the, and then 6 minus 4 power. Then we're going to go ahead and multiply this by the b's base, so we have this b, but this time we're going to have this 10 power and the 7 power, or the 10 exponent and 7 exponent. So that's going to be 10 minus 7. So using that quotient rule, we will subtract those exponents. So more simply put, we can say this is going to be a to the, and then 6 minus 4 is going to be 2, so 2nd power. And then let's see, for the b, we have b raised to the, and it's 10 minus 7 power, which is going to be 3. So that's going to be b to the 3rd power. Here's number 7. For number 7, we have this common base of x and x in the numerator and denominator, so we can use the quotient rule there. And then we have these common bases of y, so we can use the quotient rule one more time using those bases of y. Taking care of the x's first, notice that we have x to the 9th over x to the 9th, so we can rewrite this as x as that common base raised to the 9 minus 9 power, so 9 minus 9. And then dealing with the y's next, we're going to go ahead and multiply this by y raised to the what power? Well, we have 15 minus 8, so that's going to be to the 15 minus 8 power using that quotient rule again. Okay. Now, what is x to the 9 minus 9 power? Well, 9 minus 9, that's going to be 0. So that's going to be x raised to the 0th power. Hopefully you're thinking of something to do with that in just a moment. I'm just going to write it out to be super clear though. And then we have y to the, and then it's 15 minus 8 power, which is going to be to the 7th power. Now, anything raised to the 0th power is just equal to 1. So this x to the 0th power is really just going to equal 1. So 1 times y to the 7th power is just going to be 7th power. So we have y to the 7th power. That would be our most simplified expression. For number 8, let's take a look. We have these common bases of a over here. We can use the quotient property. And then we have these common bases of b, where we can use that quotient property one more time. Taking care of that common base of a, let's have a as our common base, and then we can take 14 and subtract 13, so we can write 14 minus 13 using that quotient property. And then for the b, let's see, we have b as a common base, and then we can go ahead and use that quotient rule and do 5 minus 4. So we're going to write to the 5 minus 4 power. Okay. Now for the a's, if we go ahead and rewrite that, that's going to be a to the 14 minus 13 is going to equal 1. And then for the b's, let's see what we have here. That's going to be b raised to the, and then 5 minus 4 power is going to be to the first power as well. Now we don't really have to write those 1, so more simply put, we can say this simplified expression is going to be just ab, or a to the first power times b to the first power. Here's number 9. For number 9, now we have coefficients involved as well. So we have the 6 and 9 in the beginning, and we're going to go ahead and start with finding the GCF of those. So if we go ahead and divide 6 and 9 by their GCF, divide them both by 3, then we're going to end up with 2/3. So I'm going to go ahead and write 2/3 as that coefficient in front. Then moving on to those common bases of x, let's go ahead and notice those ones. And then finally we have our common bases of y, so let's make sure we notice those as well. Now taking care of the x's, we're going to take this 2/3 out in front, then we're going to go ahead and multiply that by the base of x. And what are the exponents here? It's going to be 14 minus 3. So let's go ahead and write it as 14 minus 3 power. Then we're going to multiply this by that base of y. So we have y raised to the, and what are those exponents? We have 9 minus 4. So we can write that to the 9 minus 4 power. Okay, so let's see, we're going to take this and have 2/3 out in front. So let's put the 2/3 as our coefficient. And then we have this x raised to the what? 14 minus 3, that's going to be 11. So that's from the x to the 11th power. And then we have y raised to the 9 minus 4 power, and 9 minus 4 is 5. So this would be our most simplified expression of 2/3 times x to the 11th power times y to the 5th power. Number 10 is pretty similar to number 9, so notice those coefficients first of 4 and 8. Then our common bases of a, so we have a here and a down here as well. And finally our common bases of b, so we have b and b in both the top and the bottom. Let's start with simplifying those coefficients. So 4/8 as a fraction, their GCF is 4. So dividing them both by 4, we will get 1/2. So I'm going to go ahead and write 1/2 as our coefficient out in front. And then for the a's, let's see what that's going to be. Well, we have a raised to the, and that's going to take 17 minus 11 for those exponents. So 17 minus 11, that's using that quotient property. And then we're going to go ahead and multiply this by the base of b. And let's go ahead and use that quotient property again. We can use 10 minus 8. So that's going to be raised to the 10 minus 8 power. Okay, now 1/2 is just going to stay out in front as our coefficient. That's going to multiply by a to the, let's see, what's that going to be? 17 minus 11 is going to be 6, so that's a to the 6th power. And then we have b raised to the, and that's 10 minus 8. That's going to be 2, so it's going to be b to the 2nd power. So this would be our simplified expression. For number 11, we have another similar one where we have coefficients out in front. So we have 5 and 15. We'll divide those by their GCF to simplify that fraction. Then we can use that quotient property with these common bases of x, and then use that quotient property one more time for these common bases of y. All right, so right away, 5 over 15, we can divide those both by 5. So 5 divided by 5 is going to be 1, and then 15 divided by 5 is going to be 3. So we have 1/3. That's a simplified version there. And then we have a base of x here, so let's go ahead and write x. Now using that quotient property, we have 13th power minus that 7th power, so that's going to be 13 minus 7. Go ahead and write that as a difference or subtraction. And then we have that common base of y, so let's go ahead and write that base of y. And then we have the 5 minus 3 power using that quotient rule, so that's going to be 5 minus 3 power. Okay, so let's go ahead and just keep that coefficient of 1/3 out in front, and then multiplying that by x raised to the, and let's see, that's 13 minus 7, that's going to be 6. And then we have this y raised to the, and that's 5 minus 3, and that's going to be 2. So this would be our simplified expression. Here's number 12. For number 12, notice these coefficients of 12 and 16. We'll simplify those in a moment using their GCF. Then we have these common bases of a, as well as b. Looking at that 12 and 16, their GCF is going to be 4. So dividing 12 by 4, we're going to get 3 in the numerator. Then dividing 16 by 4, we're going to get 4 in the denominator. So 12 over 16 is just 3/4. Then we're going to multiply this by a raised to the what power? Well, that's going to be 11 minus 6 using that quotient rule. So that's going to be 11 minus 6 power. And then we're going to multiply that by our last base of b. That's going to be b raised to the what? That's going to be 7 minus 7 power. So hopefully you have an idea of what's going to happen with that, because it's going to be raised to the 0th power in just a moment. Okay, so this is going to be 3/4 as our coefficient, and then it's going to multiply by a raised to the what? That's going to be 11 minus 6, which is 5. So it's going to be a to the 5th power. And then let's see, we also have this b, so that's going to be b raised to the 7 minus 7 power, which is the 0th power. So it's going to be b to the 0th power. Now, keep in mind that b to the 0th power is just equal to 1. So we can go ahead and just not write that, because multiplying anything by 1 by the identity property means that we don't really have to write it all the time, right? So it's going to be 3/4 times a to the 5th power. That would be our most simplified expression here. For number 13, this one is also similar, but we have an improper fraction. So 18 is greater than 15. So just keep in mind the numerator is bigger than the denominator. Let's go ahead and simplify this using their GCF in just a moment. Then we have these common bases of x. We can use the quotient property. And then we can use the quotient property one more time with these y's. Now keep in mind there's a little invisible 1 for this y, so don't forget about that. Starting off with those coefficients 18 and 15, their GCF is 3, so dividing those numbers both by 3, 18 divided by 3 is going to be 6, and 15 divided by 3 is going to be 5, so we have 6/5. Keep in mind the numerator is still larger than the denominator. Then we have this base of x, and that's going to be raised to the 17 minus 12 power. So using that quotient property, 17 minus that 12. And then finally that base of y, that's going to be y raised to the what? That's going to be the 8 minus 1 power. So 8 take away 1 using that quotient rule one more time. 8 minus 1. Okay, so cleaning this up a little bit, we have that 6/5 out in front, and then we have this times x to the what power? That's 17 minus 12, which is 5. And then we have this multiplied by y raised to the 8 minus 1 power, which is just going to be the 7th power. So this would be our simplified expression. For number 14, we have this 18 and 24 as our coefficients. We'll simplify the fraction in just a moment. And then we have our common base of a and our common base of b. Okay, so 18 and 24, I think their GCF is 6. So 18 divided by 6 is going to be 3. And then 24 divided by 6 is going to be 4. So we have 3/4. That's going to be our simplified fraction there. And then for the base of a, we have a raised to the, let's see, that's going to be the 14th power minus 5th power. So it's going to be 14 minus 5 using that quotient rule. And then we're going to go ahead and multiply this by our last base. This is going to be b raised to the what power? Well, that is going to be 7 minus 4 power. Let's go ahead and write 7 minus 4 using that quotient rule one more time. Now, simplifying this a bit, we can say this is going to have this 3/4 in front multiplied by a raised to the, that's 14 minus 5 power, so 14 minus 5 is 9. And then multiply this by b to the 7 minus 4 power is going to be to the 3rd power. So that would be our simplified expression here. Alrighty, last couple. Just like in the last few problems, we're going to start by simplifying these coefficients by dividing by their GCF. Then we'll go ahead and use that quotient rule with the base of x, and then use that quotient rule one more time with the base of y. Starting with those coefficients, 27 and 18, I think their GCF is 9. So dividing 27 by 9, we're going to get 3. And dividing 18 by 9, that's going to be 2. So we're going to have 3 halves. Then dealing with the base of x, let's write that x here, and that's going to be raised to the 8 minus 2 power using that quotient rule. That's going to be 8 minus 2. And then we're going to go ahead and multiply this by that base of y, and that's going to be raised to the what? That's going to be 17 minus 9 power. Use that quotient rule one more time, 17 minus 9 power. Okay, so in front we're going to have this 3 over 2, and then multiply that by x raised to the 8 minus 2, that's going to be to the 6th power, and then multiply that by y to the, and then 17 minus 9 is going to be 8, so that's going to be y to the 8th power. So this is going to be our simplified expression. Finally, for number 16, we'll do this one more time. Let's go ahead and start with the coefficients and divide those by their GCF. Then use that quotient rule with the base of a, and then use that quotient rule one more time with the base of b. Starting with those coefficients, 30 and 18, their GCF I think is 6, so dividing 30 by 6, we're going to get 5. Then dividing 18 by 6, we're going to get 3, so we're going to have 5/3. Then we're going to go ahead and multiply this by that base of a. So we have a raised to the what power? Well, it's going to be 13 minus 11 using that quotient rule, so 13 minus 11 power. And then we're going to go ahead and multiply that by that base of b, and that's going to be raised to the 8 minus 8 power. That's going to use that quotient rule one more time. Okay, so out in front we have this 5/3, that's going to stay there. And then for the a, let's go ahead and simplify that. So it's going to be a raised to the 13 minus 11 is going to be 2, so it's a squared. And then we're going to go ahead and multiply this by b raised to the 8 minus 8 is just going to be 0. And just keep in mind one more time that b to the 0th power, or anything to the 0th power, is just equal to 1. So anything times 1 stays the same by that identity property of multiplication. So our simplified expression is just 5/3 times a squared. That would be our most simplified expression. Alrighty, so there you have 16 different practice problems on using the quotient rule of exponents. So if we are dividing these different types of powers with the same bases, a shortcut we can use is we can subtract their exponents instead of writing out all of those different multiplications. As long as we have the same base, we can go ahead and subtract those exponents, and that should save you some time. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up and sharing with a friend or classmate that might find it helpful as well. And as always, keep up the great work that you're already doing, and I'll see you in the next one.